Yeah.
I'm presuming you haven't seen these questions. First of all,
No.
can you read that, or do I need to blow it up a little bit?
Yeah, I might be able to blow it up here on my end. Oh, yeah, that actually helped a lot.
Okay, I
Um,
can do it one
yeah,
more
yeah, yeah.
time. Good. Okay, that should be.
Yeah, yeah, yeah.
It's white.
That's perfect.
We can read the whole question. Um,
Yeah,
all
yeah.
right.
That works
So
well.
if 2x and y plus 2 are inversely proportional, how can I write that as an equation?
Okay, so 2x and y2 are inversely proportional.
Mhm.
So you're making a proportion. So like 2x would be equal to 1 over y plus 2.
Yeah, only instead of 1, it's some constant, k.
Okay.
Okay? When I say something is inversely proportional to something else, in other words, if I said y is inversely proportional to x, it would be written like this. If I said y was directly proportional to x, it would be written like that.
Okay.
And then the first step is usually to solve for k. In other words, this is just a general equation that states sentence number 1. Now I can solve for k because they say when x equal 1, y equal 3. Well, if we plug that in, that gives me 2 equals k over 5.
Exactly.
So k is
Um,
10.
yes.
Now I can go back to the original equation, and there's my specific equation for this particular problem.
Okay, great.
Um, And now the rest of it's relatively easy. What's the value of 8x squared? Well, let's first of all solve for x. So I get x equals 5 over y plus 2. And now it says when y is 2, what is 8x squared? Well, x is 5/4 when y is 2. So how would I get 8x squared?
So now you're going to plug that value 5/4 in for x. You're going to square that, so that will be 25 over 16 times 8.
Okay. So it's
So
25 over 2.
exactly.
Okay, cool. All right, number 2, they love these kind of problems. If it takes 12 seconds, I won't read it out loud. I'll let you read it.
Okay.
I
It
kind of
takes
encourage
12.
students not to read it out loud because when you take the test, you're not going to be reading it out loud. You're going to be
Exactly.
reading it to yourself, so go ahead and read it, and then you can maybe describe how you're going to solve it.
Okay. Okay. First, I would divide 12 by 4 uh, to get, well, actually, no, I wouldn't. I would divide 12 by 3 because to get 4 equal pieces, you're going to have to make 3 cuts.
Exactly.
So it's going to take 4 seconds a cut. So to get 7 pieces, I'm going to make 6 cuts. At 4 seconds a cut, that's going to be 24 seconds.
Correct. Okay.
But I will note that because I
Yeah,
most
whenever
definitely.
that's common in the sense that you're always making one less cut than the number of pieces.
Exactly. It's when I was studying for the SAT, I remember it was a they would say goal posts or how many posts and spaces between the posts.
Hmm.
So I guess it's sort of analogous to that.
Yes, yes. Or if you're standing in row 2, or you're standing second in line and somebody else is standing fifth in line, how many people are between you? It's not 3, it's 2. Um,
Exactly.
Numbers 4 and 5, or 3 and 4 rather. Okay,
Which
how
I guess
about
would be
number 3? What is the value of k plus m if k and m are integers.
Okay, so uh, so this is a data sufficiency because I'm seeing the 1 and the 2.
Correct. And that's an important thing. I found out when I was working with Eric so much that a lot of times I would forget to notice that it was a data sufficiency until I looked at the answers. In other words, when you look at the question, it's not always clear that it's data sufficiency. You don't really see that until you notice that there's only two things under the question.
Yeah, exactly. The actual GMAT makes it a little easier because then I'll have the 5 answer choices and it says, and there's all the word statements after that. This is sufficient alone. But yeah, in this case, with everything on the paper, it took me another second to recognize that this was data sufficient.
Yeah. So let's write this as k over m equals 4.
Okay.
Is that enough to, in other words, that means k equals 4m?
Yeah, that's not enough. They
Clear no.
Exactly.
Now k to the m power equals 64. Is that enough by itself?
No, that's not enough either.
No, because you could have 4 to the 3rd, you could have 2 to the 6th. There's lots of combinations of k's and m that cause that to be true. Now, at this point,
okay, so now I would use substitution. So I would say,
that's exactly what I did. I don't know if there's an algebraic way to prove this, but I started experimenting with a few numbers. When you said you'd use substitution, what would you do?
I'm wondering what will put me in a better spot. At first, my immediate reaction was to substitute 4m in for k. So it would be 4m to the m power equals 64.
Yeah.
But I'm wondering if the other way might be easier to say.
Yeah, I'm not quite sure that I can solve for m there. I certainly can with some numbers. In other words, that's not a bad step. Can we come up with an m that works?
Yes. Now, I mean, we would be going with like more of a guess and check method at this point if we were to continue this course, correct?
That's true.
Okay.
That's true. And I don't know if we're necessarily going to prove it, that it works.
Okay.
But I can certainly find an m that works. And
exactly. So, oh yeah, and that's, yeah, I was getting ahead of myself a little there. That's all we have to know. So the two statements together are sufficient because you'll be able to find an m to the m power that works for
right. 2 works for m if you just try some relatively small numbers. In other words, we would have 4 times 2 squared, which is 64. And just looking at that, I can't imagine that any other number for m would possibly work. Certainly a value less than 2 is not going to work.
Yeah, exactly. And any value larger than 2 would just be too large.
Exactly. So I think in a way this does kind of prove that m has to be 2. And of course if m is 2 then k is 8. And now we can figure out what the value of k plus m is.
Okay. And I'm glad that we went about it that way. I was going to, because I did say that after seeing that, then there must, but I was not thinking about the fact that they both have to be integers. So if it was something, I would really try 2, and if 2 didn't work, I would know that 3 raised to the 3 power is, that would be 27 times 4, so that would be too high.
Right.
So I would know that m couldn't be an integer at that point.
And negative values don't work either. Notice that if I plug in a negative value, I'm going to end up with a negative number, even if it's, say, -1. Well, that's always going to be -1/4. So that's always going to be a fraction with any negative values. So I think that we kind of have conclusively proven that m is equal to 2 is the only solution. At least, certainly if they have to be integers.
Exactly.
Okay.
All right, great.
Number 4. Go ahead and read that.
Okay. Okay, so this is basically a compounded percentage problem.
Correct.
So we could do we could go by two methods here. We could either multiply 0.9 times 0.75 to come up with the percentage that will not.
Actually not. You kind of almost have to treat this as a probability problem. In other words, if 90% get caught, how many get through? Because ultimately, the question is asking about what percentage get through. So we kind of have to find the complement of this 90%. In other words,
okay, understood.
10% are going to get through from the first filter. 25% are going to get through from the second filter. And for them to get into her email account, both of these have to happen.
Okay.
So it's
exactly. So the 10% to 25%.
0.25, yeah. So 2.5%. And one of the clues here is that notice that if you do go about multiplying 90% times 75%, you end up with a number that doesn't look like any of these answers. Nothing even close. Even if you take the complement of it after that. In other words, let's say you decide you're going to multiply 90% times 75% and then take 1 minus that. Well, that gives nothing close to any of those answers either.
Yeah, it would have been around 63% if it was 90 and 70. It would have been 63, so it would have been 37. Yeah, that would have been way off.
Right.
I would have knew that I was.
There's nowhere to go from there. So.
Exactly.
Okay.
All right, awesome.
Let's look at number 5. Wow, 5 is one of those that took me a while to figure it out, and finally, after thinking about it for 20 minutes, I realized what I had to do to solve it. This is a traditional work problem.
Rate problem, yeah.
Well, it's more than just a word problem. It's a work problem.
Yeah, it's a work rate.
And GMAT is almost unique. I don't see work problems on SAT testing or ACT testing, but GMAT has a lot of work problems. And there is a formula that you can use for work problems. It goes something like this. This may be R sub 1, R sub 2, and that's T. I always found this wasn't terribly helpful. I actually find it helpful now, but Eric and I kind of came up with a way of doing work problems that I really, really liked. And let me run it by you. Let's start with a simple version. This is actually a fairly tough word problem, but let me give you a different one, and we'll go about. Let's say Sam takes 3 hours to paint a house or to finish a task, and Sue takes 4 hours. Well, working together, how long would it take them to finish the house?
It's like it's analogous to having resistors in parallel, where you're going to take the so you're going to go 1 over 1/3 plus 1 over 1/4. Well, I mean,
Well,
you're
actually,
going
you're
long.
doing this. It's 1 over 3 plus 1 over 4 equals 1 over the time. And if you add
Yeah.
those two fractions, you get 7/12 equals 1 over time. So the time must be the reciprocal of that, 12/7. Okay? But
Okay.
I actually do these. Let me show you the way I do them and see if it helps, particularly on a problem like this. Because this problem gets a little complicated to use that formula. The way I look at these work problems is if Sam, I always take it down to what part of the job can they do on a unit time basis. Well, if Sam can do the house in 3 hours, then he can do 1/3 of the house per hour. And if Sue can do the house in 4 hours, she can do 1/4 of the house per hour. Okay? So working together in opposite ends of the house, at the end of 1 hour, he's going to have 1/3 done, she's going to have 1/4 done. So at the end of 1 hour, they're going to have 7/12 of the house done per hour. And now to do the entire house, you just flip that. In other words, if you can do half the house in an hour, it's going to take you 2 hours to do the whole house. So if together they can do 7/12 of the house in 1 hour, then it's 12/7 hours to do the whole house.
Exactly.
Okay. Now, this problem, we've got 3 hours, 6 hours, and 9 hours. So Barbara is 3 hours, Ben is 6, and Daria is 9. So the way I did it was that means Barbara can do 1/3 of the task per hour. Ben can do 1/6, and Daria can do 1/9. And now it says that Ben and Barbara work together for an hour, I think.
Well, they say till half the task is done.
In 1 hour, right. Well, if he's doing 1/3 and Ben's doing 1/6, well, how much do they do at the end of 1 hour? They do half the house. That's equal to half.
Yeah.
So it's going to take exactly 1 hour to do half the house. And then they have the other half of the house to do. And that's going to be 1/3 plus 1/6 plus 1/9. And that becomes 18 is the common denominator, so 6/18 plus 3/18 plus 2/18. So they're going to be able to do 11/18 of the house in 1 hour.
Okay. 18, 11, 11 hours, but you don't need that amount done, so you are going to cut that down.
So the 3 of them would be able to do 18/11 hours to do the whole house. Well, what's half of that? In other words, they're only doing, in other words, if the 3 of them were working together from the start, it would take 18/11 hours to do the whole house, right?
Yeah, so it's just going to take 9/11 hours to do the other half.
Or 18
so we have
seconds hours to do half the house. Okay, well, now we had 1 hour. How long did it take to finish the entire task? Well, 1 hour plus 18 seconds of an hour, which is 22 seconds plus 18 gives you 40 seconds, which is 20 over 11, which is answer number D. All right.
All right. Thank you.
Let's go to the next one here. Hold on. We have to do this. Just a second. I gotta figure out how to get to the next page. Maybe I have to do it this way. There's usually an arrow here. Yeah, I'll have to do it the hard way. Hold on a minute.
No problem.
Hard way is this way. Yeah, okay. And now, let me get rid of the first one. And snap that one left. Put this one up right. Alright. And let me blow this up a little bit. Alright, is x equal to 3? And number 1 says that x minus 2 to the x plus 2 is equal to 1.
Okay. So this is going to be an exponents problem.
Well, first of all, is x equal to 3 there? In other words, just substitute 3 for x, and does that work?
Yeah.
It does work. But it's
yes.
not the only x that works. Let's see.
Yeah, exactly.
Hold on, I made some notes here. In other words, the only thing I have to do to prove that this is not sufficient is I have to find 2 different x's that both work. Okay? So x equal 3 does work, but I found another x that works, and that's x equal to minus 2.
Yeah, you'll get negative 4 to the 0, which is equal to 1.
Yeah, anything to the 0 is equal to 1. So the moment I found a second x value, then this is a null by itself.
Exactly.
Okay, now we look at the second one, which is x minus 3 over x plus 2 to the third equals 0. And clearly x of 3 works on this one also, because we have a 0, we would have a 0 in the numerator, and 0 to any power is 0. So,
yeah, exactly.
Okay, so x equal 3 works for this, but can I find another number that works?
Would be undefined if you use negative 2, it would be undefined.
Correct.
Because it would be on the bottom.
And also, that's not equal to 0. Okay?
Exactly.
That's actually equal to like negative infinity. But they say undefined.
Yeah, exactly.
So the only thing that the only number that raised to the third power that can possibly be equal to 0 is 0. No number raised to the third power is ever going to be equal to 0, and not whether it's positive or negative. And the only thing that makes this 0 is x equal to 3 as if the numerator is 0. So
with sufficient alone.
yes. So B. I do have an answer sheet on these if we need it or if you want confirmation of it.
Okay.
And I can pull it up anytime. I'd rather not set it up there while we're working through the problems, but
Yeah.
I have it available.
Yeah. No, exactly.
Okay, number 7. These are also, they love these consecutive integers.
Okay, so since it's 4 consecutive integers.
Well, and this is consecutive odd integers also.
Okay, okay, that makes sense. Because if it was 4 consecutive integers and it wasn't odd, that wouldn't work. Okay, so 4 consecutive odd integers is negative 96. So negative 94 and negative 98 are going to be our sandwiches on the inside.
No, because
so negative,
it's the sum of these. So these integers are each going to have to be about a fourth of 90.
Okay.
So if I'm going to pick a starting spot to guess, maybe I'll start with minus 20. The next one would be minus 18. That's not going to get up there, but let's go back and add a minus 22 and even a minus 24. What do these add to? Looks like minus 94. No, let's see. These three add to 60. That would add to minus 84. So I got to take off the 18 and add a minus 26. And I just increased my number by 8. And I'm going to have to go back and do at least one more, I believe.
So then would you start by dividing 96 by 4 then, like to make this a quicker problem? To say that 1/4 has to be equal to negative 24?
Yeah, you could, to figure out which number to sandwich about, and that will get you this answer. Is this the right answer? Let's see. This is minus 54 and minus 46.
Yeah, so that's going to be...
Doesn't do it.
Yeah, that's going to be...
4 consecutive odd integers is minus 96. Let's see. Let's take off that. Maybe I had it right before and I didn't see it. Minus 20.
They have to be odd, though.
Yeah.
4 consecutive odd. And
this is too
so
little.
since those were even, we wouldn't be starting with those. We would be going...
Sorry. No wonder it wasn't working. Yeah. We need to be... I apologize. So
we'll just sandwich with 23 and 25.
Yeah, certainly a start. And you don't have to be exact because you'll immediately find out where I have to add the other number. That's 52, that's 44, there's your 96 there. Okay?
Okay, cool.
And if it was less, I would add to this end and take off from that, or vice versa if I needed more, bigger numbers. And now they say, which is the largest number in the set? What's the answer?
Negative 21. Well, negative 21 should be the largest number. So I guess when they're saying the largest, they're talking about absolute value then?
No, I think it's a typo. Which of the... I didn't have it over far enough. Which of the following is the second largest number in the set?
Okay. Then that would be negative 23.
Correct.
Okay.
Yeah, they're trying to fool you to pick the largest absolute number. So it's nice that you immediately saw that with negative numbers, the smaller the negative number, the larger it is relative to the other negative numbers. Yeah, boy, what a difference a word makes, huh? Which of the
Yeah.
following is the largest number in the set? Which of the following is the second largest number in the set? Let me move this over just a hair so I get a little more of that. Tell me, and now it won't do it. Windows 10. All right. Okay, so we're looking for the ratio of R to S. And the first thing they tell you is R is 32% more than S. How can I write that as an equation?
So R equals S times 1.32.
Yeah. Is that enough to figure what R divided by S is?
Yes, R divided by S equals 1.32.
Okay. Second,
All right.
R is, how do I write this equation? R is 34 less than 2 times S.
Yeah. So R equals 2S minus 34.
Okay. Can I figure out what R over S is here?
Let's see. So put 34 on the other side.
You can't figure it out.
No. Yeah, you can't.
You can't solve for R over S to be a number. In other words, I could certainly divide both sides by S, and then I get R over S equals 2 minus 34 over S. But I haven't really solved for R over S. I've got R over S as a function of S now. So
Yeah, exactly.
to solve for R over S, you got to be able to put a number on it. And
yeah, so you can't completely isolate.
right, exactly. You cannot isolate R over S from that one. So you can't figure it out from 2. You can from 1. Problem's done.
Okay.
And that's something that you've been working so long that I'm sure you've come to that conclusion now. But when I first started working on these, it was tempting when you got something like this to see if both of them will allow it. But you're done with the problem. If one statement gives you a yes and the other one a no, you're finished. There's no point in considering anything else. No other combination could be right.
Exactly.
This one gave me fits.
Yeah,
This one gave me fits because I misread it. What this is, let me write it out the way it should be written out instead of the way I'm sure a lot of people are going to misread this. That's all over the square root of 92 minus the square root of 121 inside the radical, like that.
Yeah.
The way I read it was the denominator was square root of 92 minus the square root of 121. And I kept getting a negative answer, and I didn't see any negative answers in there. So I was really confused when I first tried to do this problem. I couldn't figure out what the mistake I was making. And finally I looked a little closer and I saw the double radical. Now, that still doesn't solve the problem, but it actually does. What's the square root of 6.25?
Okay, square root of 6.25. I'm not quite sure.
They're a little tricky. One way to look at 6.25 would be 6 1/4, which is 25/4. Notice that the numerator and the denominator are perfect squares. So the square root
okay, so
5/2. Yeah.
Okay.
Okay. So the square root of that is 5/2. Then this a little easier, the square root of 0.64. 64 is a perfect square number. So what's the square root of 64?
Okay, so the square root of 64 is 8.
So this has to be 0.8.
Yes.
In other words, if you take 0.8 times 0.8, you get 0.64. One of the things that is really worth noting, and that is that when you take the square root of numbers greater than 1, the answer gets smaller. When you take the square root of numbers between 0 and 1, the answer gets bigger. In other words, if I take the square root of 1/4, the answer is 1/2. It got bigger. Whereas if I take the square root of 4, the answer is 2. It got smaller. And so, and that's confusing to a lot of people in trying to figure out how can the square root of 0.64 be a number bigger. It's 0.8, but just testing it out, you can see that that's correct. And then what's the square root of 0.09?
0.3.
Correct. And I'll change that 5/2 to be 2.5 so we can do the math.
Okay.
The numerator.
2 plus 1/2 is 3.
Yeah, okay. Now let's look at the denominator. Well, always work from the inside out. So,
okay, so 121 would go down to 11. 92 minus 11 is 81. Square root of 81 is 9.
So now we have 3 over 9, which is 1/3.
Well, 1/3. Okay, great.
And they actually, I kind of like this problem, even though I don't tend to like problems that you can easily misread. But what I do like about this problem is that they didn't put any negative answers in the bottom. They could have put some negative numbers here, and it might have taken me 20 minutes to see I was misreading it. Because immediately, it looks like you have a negative denominator when you look at that. Because it looks like square root of 92 minus square root of 121. It's got to be a negative number.
Exactly.
So the fact that they did not put any negative answers in there is a flag that, I must be doing something really wrong. And I finally realized, oh, I see what it is.
Now, David, when you see something like number 9, or like should I be conditioned to think, like, at first when I see something like this is probably going to all be clean, and I should be finding clean numbers?
Yes. Yes.
Okay.
That was the other thing that got me, is I couldn't figure out why they had square root of 92, because that's not a clean number.
Okay.
Each of these numbers are all clean. By clean, you mean they are rational.
Exactly.
Yeah.
Exactly. Rational and can be solved pretty logically.
Correct. Correct. And 6 1/4 is just one I happen to know. That 2.5 squared is 6 1/4. It's just something I've known for a while. So it was easy for me to take the square root of that. But the easier way actually is to put it in the form of an improper fraction. 25/4. And then you see real easily that you don't need a calculator to take the square root of it. But you're right. Since this is not a calculator test, these almost need to be clean numbers to be doable.
Exactly.
Especially when all the answers are clean numbers. All the answers are rational numbers. So if it really was the square root of 92, how do you get a rational number when your denominator has an irrational number in it? It didn't make any sense.
Yeah.
Little things like that are useful. And of course, I did recognize 64 was a perfect square, and 9 was a perfect square, and 121 is a perfect square. So it does help.
Yeah.
All right. Let me make that just. Can you still read that? Because I can make a little. No, I can't. It's not letting me move that over for some reason.
Yeah, I can see that. It's just when we see exponents, I can't see the exponents. We don't have any exponents for the next 3 problems, so that's fine.
So this problem, is AB divisible by 5?
Okay, so they're both non-zero digits. Okay, so AB minus BA.
What are some choices for AB?
Um,
If it's divisible by 5, what would it have to be?
okay, so it would have to, so B would have to be either a 0 or a 5.
Right. And so what I immediately did here, and let me think about this for a second, is I said if it is divisible by 5, then possible ABs would be 50, especially since BA is then 5, and AB minus BA would be 45, and that's divisible
Which
by
is divisible
9.
by 9.
Yeah. And I tried another one. Let's try 35 divisible by 5 minus 53. Well, that's 18. That's also divisible by 9. So it looks like maybe divisibility by 9 solves it. But then I tried one more that didn't end. In other words, I made sure the AB was not divisible by 5.
Uh-huh.
That's equal to 27, which is also divisible by 9. So having AB minus BA be divisible by 9 does not tell you anything. It does not tell you whether AB is divisible by 5, because 2 of those it is, but 1 it is not.
Yeah. Now, how did you know to go to 74 and 47?
Because I wanted to pick a number that did not end in 0 or 5. In other words, all this did was confirm the fact that AB was divisible by 5. So
Okay,
I
so
wanted to pick a number that was not divisible by 5 to see whether its subtracting BA was still divisible by 9, and it was. I think I could have picked pretty much anything. If I pick 73 minus 37, yeah, we get
okay,
36, and that's also divisible by 9.
by 9.
So
Okay, okay,
divisibility by 9 does not show anything.
okay.
Okay? So
So it
number 1
seems that
is a no based on the fact that I can find 2 different ABs, both divisible by 9, and yet only one of them is divisible by 5.
okay. So when you did 74 and 47, you just put that in as random.
Exactly.
You didn't know.
Well,
Okay.
not quite random. I wanted something that didn't end in 5 or 0.
Well, yeah, exactly, exactly.
First of all, it piqued my interest a little bit that both of those were divisible by 9, because that seemed a little strange. And stranger still that no matter what numbers you pick, the answer is divisible by 9. Oddly enough.
Yeah.
Okay. So,
Okay.
so finding 2 solutions shows me that it's not enough to know whether AB is divisible by 5, because it is in this one, it is in this one, but it's not in that one.
Exactly.
So it's
Okay.
a
So
definite no on number 1.
yeah, can't be sufficient alone. Okay. So no on number 1.
And number 2 is we're adding all of these. Well, notice when I add that, I get 55. When I add this, I get 88.
88.
When I add the really weird one, I get 131. Well, again, that's divisible by 11, that's divisible by 11, but that's not. So
Okay.
divisibility by 11, when you add AB and BA, is not enough to know what AB is. Ooh,
Okay.
ooh, or hold it.
Wait, no, because
I did the logic of that wrong, yeah.
74, 47 is 121?
No, I wish it was, but it's no, it is 121. What am I thinking? Good grief. Yeah. So again, divisible by 11. But AB is not divisible by 5 there. It is there. It is there. So having the sum of AB and BA be divisible by 11 is not enough to tell you whether AB is divisible by 5 for exactly the same reason. I found 2 different ABs that both produce divisibility by 11 when added to BA.
Exactly.
Now, what did I do next? So 1 and 2 alone don't work. And then I stopped. Hold on. I'm sure I have other notes here for this problem. I don't know what I did with them. Just a second. I wonder if I wrote it on this other page. Well, let's see. Let's see if we can figure out now whether both of them together work. In other words, I don't think so.
Well, yeah, you just proved that with 74 and 47.
Right. In other words, considering both things together didn't produce an answer either. We had divisibility by 9 and we had divisibility by 11, and even when you consider both cases, you can't figure out whether AB is divisible by 5. So this would be a neither.
Together.
What is that? You know, I so rarely see these 5 answers. 1 is A alone, 2 is B alone, 3 is both together.
Yes. And then D is each alone.
Each alone, and E is neither.
Together insufficient.
Excuse me.
Well, see, so, okay, so towards the end of this problem, it says, or towards the end of the question statement, it says each represent a non-zero digit and A is greater than B. So I figured that the fact that A was greater than B was going to come into play at some point because it was specifically stated.
And in fact, that takes out that case right there, doesn't it? Yeah, I can't use that.
Yeah.
But I didn't need that case. In other words, the only cases I needed was that one and that one to prove that divisibility by 9 didn't help, divisibility by 11 didn't help, being divisible by both doesn't help either. But you're right, A having to be bigger than B, I forgot to do that.
But I'm surprised that that it was put into the statement there, but it doesn't come into play.
Seem like that's necessary, does it?
No. So that may have taken some time from me. We might have been chasing a ghost there, you know?
Although it actually maybe helps because it eliminates the number of numbers that I fooled around with 35 and I didn't need to. In other words, I should have restricted all my trial numbers to where A was bigger than B. So in a way, it limits the universe of possible numbers that you can pick.
Okay.
But it does appear to be unnecessary, at least from the numbers I picked. All right, let's look at 11.
Okay.
11, we don't need to do it the way we did the other work problem. 11 is a work problem, but there's actually a much easier way to do it. If it takes 10 workers 24 days to paint 8 buildings, how long would it take 10 workers to paint 4 buildings?
Okay, so if it takes 24 days for 8 buildings, so, all right, so I'm thinking let's take the number of days and divide it by buildings. So so it would be 3 days for 1 building for 10 workers.
That is one way to do it, but notice that 4 is exactly half of 8.
Oh. Okay, yeah, exactly. Okay, all right, great. Okay, so if it takes those 10 workers 24 days, it's going to take those 10 workers 12 days for 4.
Correct. So 10 workers take 12 days to do 4 buildings. Well, now I can just set up a simple ratio.
Okay.
10 is to 6 as 12 is But the ratio is the other way around. It's 10 is to 6 as x is to 12, because you know it has to be bigger than 12 days.
Yeah, exactly.
So you get 6x equals 120, x would be 20 days. And that makes sense.
And as you're reading through the question, you're looking for things like that, right?
Yes,
like the
definitely.
8 identical buildings to 4 identical buildings, because
specifically on a problem like this, in other words, where they have multiple workers, multiple days, and multiple tasks. In other words, this goes a little bit beyond just a standard work problem. I'm sure we could do it the way you started out to do it, which is to figure out how many buildings one worker can build in one day, and then go from there. But usually when there's this many different things, there's a shortcut. And the shortcut is to notice that 4 buildings is exactly half of 8 buildings. So I immediately know how long it would take 10 workers to build 4 buildings. And then I have a ratio I can set up.
Yeah, exactly. And this test is so much a function of time that I'm glad that you were showing me this, because if I went about it the other way, you know, maybe it takes 2.5 minutes to solve this problem where otherwise it took 90 seconds.
Yeah. Plowing into the algebra is not always the smartest thing. I like to tell people that your goal here is not to show anybody how much math you know. Your goal is to do as good on this test as you can possibly do in the shortest amount of time, basically.
Exactly.
And so just because you can do the algebra doesn't necessarily mean you should.
Exactly.
All right, let's do number 12 and then call it a session.
Okay.
Number 12 is actually fairly straightforward. I didn't see very much problems with number 12. What's the largest 3-digit positive integer where the 3 digits are not equal to one another?
Well, it has to be 987.
Yeah. And now, PQ is the largest 2-digit negative integer where P is not equal to Q.
Okay, so you were going to go minus negative 98.
Well, what does PQ have to be? What's the largest 2-digit negative integer?
So that's going to be 98, right?
12.
Wait. Oh, okay, yes. The largest negative, so it has to be the smallest. Okay.
Negative 12 is larger than negative 98.
Yeah, exactly.
They can't be the same. The only question I had about this problem was, does 0 count? In other words, how come 0, 1 isn't the largest 2-digit negative number? But I guess they would say that that's not a 2-digit number. Because when I first did it, I used negative 1, and I noticed there was no answer on there for 987 minus a negative 1. Yeah,
because it's saying 2-digit negative.
Right.
Yeah, no, exactly. It's worded pretty poorly.
It kind of is, because I'm not sure that somebody couldn't call 05 a 2-digit number.
Yeah, because that is a 2-digit number. Yeah, I guess what they meant to say was 2-digit negative integer where each digit is a negative integer.
Right, where each digit is a negative integer, because 0 is neither positive nor negative.
Exactly.
So it is even. It's worth knowing that in terms of number theory. But anyway, I came to the conclusion it had to be minus 12 that they were talking about. And then when you take 987 minus a minus 12, you do get 999, which is an answer on there. So. And that's the correct answer also.
All right. Yeah, and I see that the wrong answer was also there for me. Hopefully I would have figured out when I did the minus negative 98.
If you pick 98, right. Yeah, you're right. When you add 98 to that, you get No,
Well,
that wouldn't.
well,
It wasn't
I would have went minus negative, so it wouldn't have been an answer, and I would have
right.
realized that that
You'd have
way.
caught your mistake. And frequently, that's a great technique. In other words, if you do the problem and you come up with an answer and it's not on there, you know you did something wrong for sure.
Yeah, yeah, exactly.
And then it's just a
Good.
question of figuring out what it was.
Yeah, it's the nice part about these multiple guess.
Yes. Yes. All
Okay,
right.
all right, awesome.
Let's see. You signed up for 9 a.m. tomorrow morning, correct?
Yes, I signed up for
Yeah,
9
9
a.m.
o'clock. I'm wondering, is that, could you do 10 or not? Does
Yeah.
that interfere with your schedule?
No, no,
Could do 10.
that's fine.
I'm thinking that if we move you back to 10, it's going to give me more time to prepare and look at those specific stuff that you wanted me to.
Okay, all right, great. Yeah, no, I
Is that
very much
okay?
appreciate that.
I mean, because I
Yeah,
could
and
do 9, but I'd rather have a little more time to
okay,
prepare for it. So I'm just going to move you back to 10 here, and
okay.
I will
If
text you the meeting ID at 10.
Okay, now if you feel like you need more time than that, I wouldn't mind a later time either. Whatever works for you. Um, I've
About 11. 11 is actually perfect for me.
okay.
That
All right,
gives
sounds
me
good.
plenty of time to cover enough material for at least an hour session.
Okay,
I'll
all right,
cover
awesome.
the points that you asked me to look at, and then when we get done with those, we can just continue on with these practice tests. I think these practice tests are, I don't know if they're the way to go. I do like the fact that you're focusing in on areas that you don't feel as comfortable with as other areas, and certainly it makes sense to focus on those also. But
Yeah,
it's tough to beat the practice tests.
yeah, exactly. And I do want to go through practice tests together.
Mm-hmm.
I'm thinking that I'm now there was there was an Excel spreadsheet that I sent a little while back.
Right.
After I'm able to clear those red items,
Okay.
that's what I'd like to transition into
Okay.
doing practice tests.
Okay.
But for now, I'd like to get those items out of the way.
Okay.
That way I can take practice tests on my own too, and not and if I get a score back on a practice test, I can take it as such, not like, oh, well, I didn't know that unit yet, and I didn't know this unit yet.
Right.
Like we were doing a problem that I would have gotten wrong, and it was a probability problem, so or it was like a probability problem. So I've got it was the percentage problem where 90% wouldn't get through the one firewall and 72 wouldn't get through the other.
Yeah.
But
the secret on
yeah.
the secret on a lot of probability problems is turning it into the complement.
Yeah.
In other words, if there's a 30% chance it's going to rain today and a 30% chance tomorrow, what's the chance it's not going to rain at all? Well, that's 70% the first day times 70% the second day. So 49% of the time it would not rain at all, which means 51% of the time it would rain at least one of the 2 days.
Yeah.
But so probability problems tend to unfold that way also, where you have to take the complement of the probability.
Okay.
But okay, well, 11 sounds good tomorrow. I will talk to you at 11, my time.
All right.
I'm not sure. Where are you at?
I'm sorry?
Where are you located right now? You're in...
Okay, so last time I was in Virginia. This time I'm down in Florida.
Okay, so you're still on Eastern time zone, so that's like 1 o'clock for you. Okay.
Yeah, exactly.
Okay. I'll talk to you tomorrow, Matthew.
All right. All right, looking forward to it, David. See you then.
Bye-bye.
Bye.